Here we have a few problems. So let's start off 1, 2, 3. And what's key in this is we notice how to compare it to one of these two forms. So what gives away this first one as being likely to be this form is the fact that you have this square root, right? So there's a square root here. Then in this one, there's a square root as well. So, and you also have the minus, gives it away. X squared, something squared gives it away. But anyways, the square root is what differentiates it from being arctangent, right? There's the arcsine one and there's the arctangent one, right? Arcsine and then arctan. And yeah, you want to be able to know when to use each one, but to start off, in any which case, right, you want to start off by factoring out that 7. That 7 is just completely unnecessary for our purposes. 5x squared. Now, in this case, it's actually an easy case because in this case you can kind of just see that 5x squared, you wanna have that let that play the role of u squared. And with that, you can then get what you want to make. So you want to do a u substitution, but now you just take the square root of both sides, right? So I know u squared is going to be 5x squared. So when you take the square root of both sides, I could distribute as the square root of 5 times x, right? Because it's going to be the square root of 5 times the square root of x, and the square root of 5 stays. The square root of x squared, times the square root of x squared is just x. And then I differentiate. Du is just square root 5 dx. I solve for dx, if you like, as 1 over square root 5 du. And I substitute everything in to this problem. Now, one side is that I substitute everything in. 1 over the square root of 1 minus, instead of writing 5x squared, right, well, u squared we should see is 5x squared, so it's 1 minus u squared, and then instead of writing dx, I write 1 over square root 5 du. The square root 5 can come out, 7 over square root 5, the integral from 1 over the square root of 1 minus u squared du. And now at this point, I should be able to tell that it's of this form, right? A squared minus u squared, right? So it's going to be a is 1, and this antiderivative, just this piece here, is arcsine of u over a. And a in this case is 1. And it's 7 square root 5. And then u, I should see, is square root 5x, and there's a plus c here. Alright, so it's 7 square root 5 arc sine square root 5 x plus c. And that's the first one. Now, the second one that we have over here, okay, it's actually not as simple, believe it or not, as simple as the previous one. This one, again, you can start off by just factoring out the 8, but also inside that square root, you can factor something else out. So inside the square root, I kind of want to make it in some way look like an a squared minus u squared. So let's compare, right? So here I have it where it's 1 minus 50x minus 5x squared. How am I going to get that to look like a squared minus u squared? So the way that you want to do this is you need to first know that you got to complete the square. You want to put it as 1 minus, and I'm already going to start trying to make it look like that by factoring out that 5, and I'm going to get then, if I switch the signs, I'm factoring out a negative 5. It's x squared plus 10x dx. And we should see immediately at this point that these two things are the same, right? If I distribute that 5, I get negative 5x squared minus 50x, and it's in there. Now, the thing that's not so clear is that I need to now complete the square on this piece right here. Because then I'll be able to say that it's of the form a squared minus u squared, right? I want to get that inside part to being like a squared minus u squared. That's the trick in this. So to do that, I have to complete the square on this x squared plus 10. So this x squared plus 10x plus something. I want to complete the square. I want to make it a perfect square. So I always take the 10, take the number next to x, I divide it by 2, I get 5, and then I square it, and that's my magic number, which will be 25. So now I rewrite it again. 1 minus 5x squared plus 10x plus 25 dx. And this, but the thing is that when I added this 25 in, right, we have to remember that I'm changing this. And I can't do that. Look, I put an extra negative 125 in this, right? So I got to add an extra 125. Look, I put in a negative 125 because when I distribute the negative 5, I get negative 125. So then this becomes, right, when I add the extra 125, it's going to become the 1 and the 125 combined to 126 minus 5. And now, since it's a perfect square, this is x plus 5 squared dx. And then it's the integral, and then there's the 8 on the outside. And basically what we did, right, or what we should convince ourselves of is that this inside value is the same as this. If you were to FOIL out the x plus 5, you get this. If you were to distribute that negative 5 to every single term, you would get negative 5x squared minus 50x minus 125 plus 125 would cancel out. So it would be 1 minus 5x squared minus 50x squared, and you'd get back the original. So this here, I just changed it so that way I can kind of realize that if I squint and I'm like, you know, maybe done this a couple times, that this is like a squared, and then this right here, this whole thing, is like u squared. And then it's a squared minus u squared, and then I have it in this form, a squared minus u squared. Okay, and that's the trick here, right? So if a squared is 126, then that means that a is the square root of 126, right? A squared should be that 126. That means that a is the square root of 126. Now u squared is 5 times x plus 5 squared. So what does that mean? U is the square root of 5 times x plus 5. And that, again, I just take the square root of both sides, and then when I do that, I could distribute the square root to the square root of 5, and then the square root of x plus 5 squared is just x plus 5. Now, du. If you do the derivative of this, you should see it that it's just the square root of 5 dx. And I solve for dx, and then I substitute, and I will have the form I want, and I probably will be able to do my antiderivative. So let's see what I get. 8 integral from 1 to, this is a squared is the square root of 126 squared, so maybe I should just even put it square root of 126 squared minus u squared for sure. U squared du is 1 over square root 5 du. So I take out that square root 5, 8 over the square root of 5, the antiderivative of 1 over the square root of 126, that says, squared minus u squared du. And now I can see that it really is of this form. A squared minus u squared, right? What is it? It's square root 126 squared minus u squared. Now I write that this is going to be equal to 8 square root 5, and then arc sine of u over a. U over a is the square root of u over the square root of 126 plus c. To finish this one, finally, to finish this one, right, 8 over square root 5 arc sine. Instead of writing u, you write square root 5 times x plus 5, which is what u is, over a. A is the square root of 126 plus c, and you're done. Whatever this is, that is your final answer for number 2. Now number 3, it's a similar thing for number 3. So let's see. So let's get this tool here. Okay, and I'm just gonna write 3 right here. So I got all this space now, right? 3. Right. So 3 is is asking for the antiderivative. I factor out the 4 right away. I'm not even gonna bother wasting. X squared minus 4x plus 9 dx. Now in this case, okay, I don't have it where I have it as inside the square root in that denominator, right? So it doesn't look likely that it's going to be arc sine in that situation. In this situation, it's going to be this other one. It's going to be the a squared plus u squared antiderivative. And you want to know how to use that in this case. So how am I going to make this look like this, right? This is your goal, right? You want to make it look like 1 over a squared plus u squared du is equal to arctan, right? Arctan of u over a plus c. Alright, so you got to make it look like this. And the way to do that, again, is by completing the square on this inside thing here. So how do I complete the square on this one? Same idea, okay? But you forget about the 9 for the time being. So the 9 is way over here, and then you complete the square on the x squared minus 4x. So what's the magic number in that case? The magic number is 4. Why is the magic number 4? So it's x plus 4, right? And then plus the 9, but you should minus the 4, right? So it just goes back to the same thing. But you want to remember this here now, you created your perfect square. But how did you get that 4? Let's go back. How did we get this 4? Wait, what? Forgot to say. How did we get this 4? Where did this 4 come from? I'm confused. Okay, now let's go back. Let's look. Forget about the constant term. Okay, you got x squared minus 4x. You take always the number next to x, which is, in this case, negative 4. You divide by 2, and then you square that value. So negative 4 by 2 is negative 2. I square it, I get 4, and that's where I got this 4 from. Now, I completed the square. Now I want to factor the completed square. So that becomes x minus 2, all of that, squared, plus 5 dx. And I should write the dx up here as well. Don't forget the dx's. Now, this is perfect. This is the form that I needed in, because now I can kind of tell that u is going to be x minus 2, and a is going to be the square root of 5. And then I'm done. And I just got to apply that. So let's understand. So we got u is going to be x minus 2. We should just see that. Du is just going to be dx. And that makes things very easy for me to evaluate and substitute, because now I have 1 over u squared plus the square root of 5 squared. which is just 5, and then du. And if I write this a little bit backwards, if I write it square root of 5 squared is a squared, right? And then u squared is the u squared part here. What is this antiderivative going to be? You're going to get 4 times arc tan of u over a is the square root of 5 plus c. And then finishing this for arc tan, go back for what u is. U is x minus 2 over the square root of 5 plus c. And by this point right here, you are for sure like, no way can I do this. But you can do this, and you will do this. And when you get to this point and you get this answer and you're like, oh, I am in disbelief that I'm doing this, you're going to be able to do it. And then you're going to try the next one. And you're going to make a bunch of mistakes on the next one, but you're going to see that you could remedy those mistakes. And then you're going to do the next one. And then maybe on the next one, you'll make only one mistake. And then on the next one, you won't make any.